Now question number 76. Correct order of lambda max. What is lambda max? That is absorption maxima of the following complexes is. We have these complex ions. You can clearly see this is CrCl6 3 negative, CrNH3 6 3 positive, and CrH2O6 3 positive. So this value of lambda max we can find with the help of crystal field splitting energy of octahedral complexes, because we know that in all of these complexes 6 ligands are there. It means these all are octahedral complex ions, and here we need to just check their crystal field splitting energy. And one more thing, what's the relation between this energy and lambda value? This is the inverse relation. Now one more thing, if I talk about the crystal field splitting energy for these octahedral complexes, these depends on ligand's field strength. And if I talk about the field strength, NH3 strongest ligand, then H2O, and after that there is Cl negative. So these are the ligands with their order of field strength. So on that basis, this lambda naught for this NH3 is maximum, and for Cl negative it is minimum. So on that basis, lambda max is maximum for Cl negative. Then there would be the term for H2O, and after that there would be the term for ammonia, NH3 ligand. Now this would be the order. So on the basis of their numbers, these are 3, 2, 1. These are given, numbers are given. So we can simply say in this case the Cl is there in the first compound. So first, after that H2O as the ligand that's present in the third complex ion, and after that second one. Where this order is given 1, 3 then 2, that order is correctly given in option number 1. So on that basis you can simply choose option 1 as your correct answer. After that, question number 77. Assuming the complex follow EAN, effective atomic number rule, find X in the complex that's given. Molybdenum is the central metal atom, and CO, this is carbon monoxide, this is the ligand here, and we need to find out the X value. If I talk about the EAN rule, here we need to know the atomic number of the nearest noble gas. That's the next noble gas. In that case, it is xenon with atomic number 54. So EN for this complex is 54, and its value is equal to the atomic number of central metal atom minus its oxidation number. In carbonyls, the oxidation number of metal is 0. So that's why I'm not writing here. After that, if I talk about the number of the electron donated by this ligand, 2 electrons are donated by per carbon monoxide molecule. So I'm just writing here 2, that is equal to 54. And if you solve this, you will find that X value is equal to 54 minus 42, that is 12 divided by 2, 6. 6 is the value of X. That's why option 4 becomes the correct answer for my question. After this, question number 78. In N2O5 molecule, AB, W, X, Y, and Z at the bond lengths of indicated bonds. We have to look at the structure given here. The bond between nitrogen and oxygen is A, and nitrogen and oxygen at this side is B. Further, nitrogen, oxygen, which are doubly bonded at this side are having the bond lengths X and W respectively. And after that, here is a coordination bond Y and Z. They have the names Y and Z. And now, which is the correct for X, Y, Z, A, B and W? We need to just find out the relation between them. First of all, I need to just draw the structure here. We can represent it as O negative. This way, this can be the structure of this. And here is the resonance between these species. Similarly here also. And this way. So that will make this nitrogen positive, both the sides. So this can be represented as O negative. This way, here's the double bond this way. So you can clearly see that this nitrogen oxygen bond and this nitrogen oxygen bond are showing partial double bond character. Similarly, these two are also the similar type of bond, and that is why they have the same bond length. But if I talk about this nitrogen oxygen bond, this is a single bond, and definitely the bond length of a single bond is more than that of the bond length of double bond. So that is why in this case we can simply say A and B are equal, because these are representing nitrogen oxygen single bond. After that, if I talk about X, Y, Z and W, these are also equal because these are representing the resonance. These are showing the partial double bond character there, and these are equal. So the bond length of single bond is more. That's why this would be the order. And if it is the order, we need to just check the option to identify that order. That's correctly given here in option 1. So just choose option 1 as your correct answer. After this, question number 79. Which of the following has an unusual property of diffusing through most commonly used laboratory materials such as rubber, glass or plastics? That is due to molecular size. If I talk about helium, that is a very small molecule, and these can be escaped from the materials like rubber, glass or plastics. That's why I'll choose option 3 as my correct answer. After this, question number 80 is here. Which of the following allotrope of carbon has delta H formation? Standard enthalpy of formation is 0 for which of the allotrope of carbon? You need to identify. So I just want to tell you that if I talk about graphite, that is thermodynamically most stable allotrope of carbon. That's why its standard enthalpy of formation is assumed to be 0. That's why I'll choose option 3 as my correct answer.